Let's have a look and see whether the following function is both one-to-one and onto. Notice in this case, the function goes from the real numbers to the real numbers. So this means we can input integers, we can input decimal numbers. So let's go ahead and see if f of x is equal to 2x plus 1 is both one-to-one and onto. So the first thing we should check is whether or one it is onto. So let's go ahead and do that real quick. What does it mean for it to be on one-to-one? One-to-one means that if you have a specific output, there is only one input that could have gotten you that. There aren't two different inputs that could have gotten you the same output. So let's have a look at 2x plus 1. Can you get 0 using only one input? And the answer probably is going to be yes. How do I know this? Well, let's rearrange for x. What does x have to be here? Well, it's going to have to be -1 over 2 is what x will have to be. And it can't be anything else. It can only be that, right? Using our algebra. So yes, it's true that this is a unique output. There's a unique input for it. What about 1 is equal to 2x plus 1? Well, x here will have to be 0, which is also going to be a unique input. There's no other input you can put in for x to get 1. Okay, let's have a look at -1. -1 is 2x plus 1. Well, what do we have to do? Well, x would have to, in this case, be equal to -1, I think? Yeah, because you subtract 1 from both sides, you get -2 is equal to 2x, and then divide both sides by 2 is -1 is equal to x. So yeah, the only input you can have for x in order to get -1 from 2x plus 1 is going to be if x is equal to -1. So this is also very distinct and unique. So x here would have to be -1, so there we go. Okay, fantastic. Let's try some big number like 5. What does x have to be in order for us to get 5? And the answer is going to be, well, rearrange both sides is going to have to be 2. X will have to be 2 here, and it can only be 2. You can't put something else in here. So it's looking like this is most likely going to be one-to-one because I can't think of a real number that you cannot get from an input here. Let's go ahead actually and try. We've tried positives and negatives. Let's maybe try some decimal numbers, right? Because the real numbers include decimal numbers. So let's try something like 1/2 is equal to 2x plus 1. What would x have to be here? Well, it would have to be 1 over 2 minus 1 is equal to 2x. And then you'd have to say 1 over 2 is equal to 1 over 2 minus 1, or minus 1 is equal to x. And if we want to expand those brackets, that means 1 over 4 minus 1 over 2 is going to have to be x, which is going to have to be -1/2. So x would have to be -1/2, I think. Give me just a moment to think about that. No, I'm wrong. It would have to be -1/4. Right? Yes, because 1/2 minus 1 is going to be -1/2, and then divided by 2 is going to be -1/4. So yes, it's true that for this real output, we would have to have a specific input of x being -1/4. So there we go. What about something like -1/2 is equal to 2x plus 1? Put 1 on the left-hand side, that's going to be -3 over 2 is equal to 2x. Divide both sides by 2, it's going to be, x would have to be -3 over 4 and nothing else. So yes, it's looking like I really can't think of an example of an output that would need two separate and different inputs to get the same output. So I do think this is going to be one-to-one. That's great. Let's go ahead and now try and think of whether or not this is going to be onto. Let me just quickly mark that it is in fact one-to-one. Okay, is this onto? What does onto mean? Onto means that you can get any real number using this equation. So we've already tried a lot of numbers, integers and decimals. Well, we've tried 6, I think, or 4, 6 or 7 maybe, which is quite a lot. You shouldn't try any more in a test. So a quick hack I like to use is I like to say, well, let y equal to 2x plus 1, right? Oh, in this case, y would need to be a real number and x would need to be a real number because, and this would also have to be a real number because we're dealing with real numbers here. So if we rearrange for x, is there any limit to what x cannot be? Are we going to get something like something over x, right? Are we going to get something like this, which in this case we would say x can't be 0, right? So are we going to find something like that, or like square root of x, and then we're going to say, well, x can't be negative. So these are the things we want to look for to see if that it's not 1 onto. So let's rearrange for x. This is going to be y minus 1 over 2 is equal to x. And yeah, it looks like y can really be anything. You can put anything into here and x will be a rational number. There's no limits here, you know, there's nothing like y can't be 0 or y can't be a negative number or something like that. So it looks like, yes, it is also going to in fact be onto. So let's go ahead and prove that this is in fact true. Okay, so let's start our proof by, of course, defining our function. We say, let f be a function from the reals to the reals such that f of x is equal to 2x plus 1 for some input x in the reals. Okay. We say, then let a and b, we're going to first prove that it's 1 to 1. So what do we say? It's a for all. So we say let a and b be real numbers such that we want to suppose this, and then we want to show that this must be true. So we say such that f of a is equal to f of b. Fantastic. We say next, f of a is equal to 2a plus 1, and f of b is going to equal to 2b plus 1. So 2a plus 1, or let me write that down in the line below. So 2a plus 1 is equal to f of a, and then we know f of a is equal to f of b, and we know f of b is equal to 2b plus 1. So 2a plus 1 is equal to 2b plus 1. Let's replace this with a then because I've already used this. So we can now say, therefore, divide both sides, or no, it's not divide both sides. Subtract first, we want to subtract a 1, and then divide both sides by 2 in order to show a has to equal to b. Subtract 1 from both sides to get 2a is equal to 2b, and divide out 2 from both sides to get a is equal to b. So there we go. We've shown that when this is true, this is true. So the function is in fact 1 to 1. So the function is 1 to 1. Fantastic. Okay, so just so we can more clearly highlight this, we've shown that this is 1 to 1. Fantastic. Now let's write down the proof for that it is also onto. So what do we say? How are we going to prove that it's onto? Because this is a there exists statement, right? Well, it's a for all there exists. So we would say let y be a real number. Yeah, okay, we can do this. So because it's a for all, we begin with let. We say let y be a real number such that y is equal to f of x, which is equal to 2x plus 1. Okay, now we want to show that there's no restriction on x. So I'm thinking we just rearrange this for y. So we say, then rearranging for x, we find, now you might want to insert here the steps like I did here for getting A is equal to B, you might want to write these steps here for what you would do. You would say subtract both sides by 1, divide both sides by 2, and then you get x is equal to y minus 1 over 2. So, oh, and we say where y minus 1 over 2 is a real number, so x is a real number always for any real number y. So we've shown that it is. So f is also on 2. There we go. It's a bit of a shorter proof in that last part, but this is generally the reasoning you would probably want to use. You'd want to rearrange for your input and show that, hey, there's no output that you wouldn't be able to get. And you show that by saying, well, your output is exactly what your domain is, always. So, or your input can be your domain. Your input can get your codomain always, is what I'm trying to say. So there we go. We've proven that this statement is in fact going to be true. That it is true that when f of x is equal to 2x plus 1 from the reals to the reals, that it is going to be both 1 to 1 and onto.